All right, in our fourth and final video on factoring beyond our basic factoring methods, we're going to look at 10 great factoring problems. All right, first one. Let's factor 3x to the 19th plus 7x to the 18th minus 10x to the 17th. Okay, let's see. Greatest common factor is always the first thing that we should look for. We're going to put a lot of them in our problems. I don't see a common factor between 3, 10, and 7. I'm sorry, 3, 7, and 10, but certainly with the x's. So we'll factor out an x to the 17th. Leaves us with 3x squared plus 7x minus 10. Okay, then count the number of terms. There are 3 terms here. So you can use guess and check, or if you know another method. I'm going to do what we did in the previous video. I'm going to do the AC method. And most textbooks or computer homework programs like my math lab don't write the AC method using this box to collect, this X box to collect their information in, but they do the AC method still. So A times C is 3 times negative 10 or negative 30. So in the bottom, we put B, which is 7. So we're looking for 2 numbers that multiply to be negative 30 and add to be 7. So 1 and 30, no. 2 and 15 can't add to be 7. 3 and 10 will add to be 7. If 1 is positive and 1 is negative, namely the 3 is negative and the 10 is positive, which is good. That'll make a positive 7. That also gives us a negative 30 when we multiply. So those are the numbers we want. So here we go. X to the 17th stays on the outside. And remember, we use these numbers, the negative 3 and the positive 10, to break up the 7. So negative 3x and plus 10x is how that 7x will be broken apart. And then minus 10. Okay. The reason for doing that is now we can group those 2 pairs. So keep your x to the 17 out front. Now, I happen to put the negative 3x first and the 10x second. It doesn't matter. You could have switched it around. Your GCFs will look a little different, but you can still do the problem just fine. The way we wrote this, 3x squared and minus 3x, we can factor out a 3x from each one. And when we do that, we're left with an x minus 1. Okay, bring down the sign in the middle, which is a plus. And between a 10x and a 10, we can take out the 10, again, leaving us with x minus 1. So here's how we're going to write our answer. X minus 1 gets factored out, and what's left over is 3x plus 10. With the x to the 17 from step 1 written in front. Okay, let's do another one. For example number 2, we're going to do a slightly different type. We're going to do x to the 10th plus 8x to the 5th plus 12. What's important to notice about this problem is if we did a substitution, which we've been doing substitutions off and on throughout all of factoring, where we let r equal x to the 5th. You'll see why in just a second. Notice that r squared is x to the 5th squared. And remember, when you square something with an exponent, you multiply the exponents together. So 5 times 2 is 10. So r is x to the 5th, and r squared is x to the 10th. So I can rewrite this r squared plus 8r plus 12. So this is what we would call quadratic in form. Which means it fits into the format, instead of ax squared plus bx plus c, it's a somebody squared plus b times that same thing plus c. So this x can be a variety of different things. What's cool about this is r squared plus 8r plus 12 is actually really easy to factor. We're just looking for two numbers that multiply to be 12 and add to be 8. It's a shortcut problem because the coefficient is 1, and those two numbers have to be 6 and 2, both positive. And since it's a shortcut, we're done. It's r plus 6 and r plus 2. The only problem is the question wasn't in terms of r's, the question was in terms of x's. So when we do these, we have to remember to go back to r was actually x to the 5th. So this is x to the 5 plus 6. X to the 5 plus 2. Now some of you may find you can skip from here to here and not do that substitution for many of the problems if you notice that the first exponent is double the middle exponent, and then there is a constant only on the third term. So I'll say that again. The first exponent is twice or double the middle exponent, and then there's a constant. That's what quadratic in form means. The first exponent is double the middle exponent, and then only constants at the end. And when we do that, when we go to factor it, the middle exponent, the x to the 5th, is how our form factors. So let's try a bunch of these. For our third example, let's try x to the 22 plus 6x to the 11 minus 7. So notice this is also quadratic in form. The first exponent, 22, is double the middle exponent, which is 11, and then there are no x's. It's a constant at the end. So if I'm going to do the substitution, which I'm probably going to need in one or two examples here, the substitution would be let r equal x to the 11 from the middle, so that r squared, or x to the 11 squared, is the x to the 22. So I've got r is x to the 11 and r squared is x to the 22. So this becomes r squared plus 6r minus 7. Very easy to factor. Two numbers that multiply to be negative 7 but add to be 6 are 7 and negative 1. So this factors to r plus 7 and r minus 1. But we have to answer in terms of x's because that's how the question came. So r was x to the 11 plus 7, x to the 11 minus 1. And again, if you can skip this stuff in green here and just go without doing the r substitution and go straight to the answer, that's totally acceptable. Let's do the next problem. Okay, so let's now factor x to the 6th minus 11x to the 3rd plus 24. Okay, so if we were to do our r substitution, because we do have quadratic in form again, first exponent is double the middle exponent and there's no GCF, then we would let r be x cubed, so r squared is x to the 6th. So this is r squared minus 11r plus 24. Again, that should be pretty easy to factor. Two numbers that multiply to be 24 and add to negative 11 are 8 and 3, as long as they're both negative. So we have r minus 8 and r minus 3. Okay, going back to x's, this would be x cubed minus 8, x cubed minus 3. a crucially important step. We can still factor in this problem because we have the difference of two cubes in technically in both problems, but since I do know what number cubed gives me an 8, and I do not know what number cubed gives me a 3, I'm going to leave this x cubed minus 3 alone. So I'm going to factor the first one, x cubed minus 8. I'm going to write it in the format we were just practicing in part 3 of Beyond the Basics. Somebody cubed minus somebody else cubed. So x to the third gives us x cubed, and 2 cubed gives us 8. So the a in that formula is x, and the b is 2. And if you remember the formula for the difference of cubes, it went a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So for us, a minus b would be x minus 2. A squared is x squared plus, multiply them together, x times 2 is 2x, and then always positive, plus b squared. 2 squared is 4. And then I'm going to write the x cubed minus 3 at the end. Again, the only reason I'm not factoring that is I don't know the cubed root of 3. I don't know what number multiplied by itself 3 times is 3. That's a decimal, so I'm going to leave it like that. You can leave these in any order that you want to. This is a perfectly acceptable order. So we have our answer is x minus 2 times x squared plus 2x plus 4 times x cubed minus 3. Okay, let's do another one. Okay, let's do number 5. X to the 2/5 minus 8x to the 1/5 minus 20. Okay, this one is another quadratic and form problem. We have 2/5 is twice 1/5. So we can do it with that r substitution, always letting the r be equal to the x on the middle term, x to the 1/5. When we square that, x to the 1/5 squared, remember 1/5 times 2 is 2/5. So we have r squared minus 8r minus 20. Okay, once you get there, it's a pretty easy problem to factor. We're looking for two numbers that multiply to be negative 20 and add to be negative 8. It has to be a 10 and a 2 if the 10 is negative and the 2 is positive. So we have r minus 10 times r plus 2. But don't forget to go all the way back to x's. Remember, r was x to the 1/5. So I have x to the 1/5 minus 10 times x to the 1/5 plus 2. Great. Number 6 is really similar. So let's do number 6 also. Number 6 is x to the negative 2 minus 2x to the negative 1 minus 15. So again, notice the first exponent is twice the middle exponent. Negative 2 is negative 1 times 2. So same idea as the last one. I'm going to let r be x to the negative 1 so that when I square that, I get x to the negative 2. So this becomes r squared minus 2r minus 15. Cool. Okay, lovely problem to factor. Two numbers that multiply to be negative 15 and add to be negative 2 are negative 5 and 3. So this factors to r minus 5, r plus 3, which would make this x to the negative 1 minus 5, x to the negative 1 plus 3. Okay, let's try a couple more like that. All right, number 7. Number 7, x to the 9.2 plus 12 x to the 5.1 plus 36 x. Okay. We have a problem. It's not quadratic in form. 9.2 times 2, or I'm sorry, 9.2 is not double 5.1. But we do have a greatest common factor of x's here. So let's factor that out. Now remember, when you're factoring this out, you're subtracting. So this is 9.2 minus 1, which would be x to the 8.2. The middle term would be x to the 5.1 minus 1 from the 1x. So this would be 12x to the 5.1 minus 1 is 4.1. And then finally, 36x, when we factor out the x, is just 36. So plus 36. Oh, thank goodness. Now we do have quadratic in form. 8.2 is double 4.1, and there are no x's. There's a constant term at the end. So now we can factor what's left in the middle. So we're going to let r be x to the 4.1. So that when we square both sides, we get x to the 8.2. So this will turn into, in the middle here, this will turn into r squared plus 12r plus 36. Again, pretty nice to factor. Two numbers that multiply to be 36 and add to be 12 are 6 and 6. So this is going to be r plus 6 and r plus 6. And going back to x's, don't forget our GCF that we had on the outside. This is x to the 4.1 plus 6 times x to the 4.1 plus 6. I feel a little silly writing that twice. Let's write this x times x to the 4.1 plus 6 quantity squared. Very cool. Okay, last few. Okay, number 8. 7x to the 18th minus 2x to the 8th minus 5x to the negative 2. Okay, here we go. All right, factor out the GCF, which is the smallest x. So factoring out x to the negative 2. Don't forget, that means we're subtracting with our exponents. So this will be 7x to the 18 minus negative 2 is 20. Minus 2x to the 8 minus negative 2 is 10. And then minus 5 x to the negative 2 and x to the negative 2 will cancel, so I'm done. What we have here now is quadratic in form on the inside of the parentheses. 20 is twice 10, so we can do a substitution where r is x to the 10th. So r squared is x to the 20th. So we would have in the parentheses 7r squared minus 2r minus 5. Unfortunately, there's that 7 there, so the factoring isn't very hard. But when we go to do the AC method, 7 times negative 5 is negative 35. So we need to find two numbers that multiply to be negative 35 and add to negative 2, which would be 5 and negative 7. And remember, we use those to break up the middle term. So this is 7r squared plus 5r minus 7r minus 5. And remember, it doesn't matter what order I write those red numbers in, just as long as they're both there. So now I have a grouping problem. 7r squared plus 5r, we can factor out an r, leaving us with 7r plus 5. Really important to remember to bring down that negative sign in the middle. Man, there is no common factor between a 7r and a 5. So if you don't have a common factor, factor out a 1. That's always okay. Now remember, because of the negative, you're not factoring out a 1. You're actually factoring out a negative 1. So negative 1 divided into negative 7r is 7r. And negative 1 divided into negative 5 is plus 5. So this factors to 7r plus 5 times r minus 1. Okay, that was just for inside the parentheses. So I'm going to do two things at once. I'm going to rewrite that x to the negative 2 GCF out front, just so I don't forget it. And then 7r plus 5, that was x to the 10th. So 7x to the 10th plus 5, and x to the 10th minus 1. Awesome. Last two problems. Okay, so to give us the next two, what multiplies by itself 3 times to be x cubed is x, and what multiplies by itself 3 times to give us 1 is 1. So a is x and b is 1. So going up here, we have x to the negative 100 and x cubed plus 9 will stay. And our sum of two cubes is a plus b, a squared minus ab plus b squared. So for us, a and b are x and 1. This is x plus 1, x squared minus 1 times x is just x, and 1 squared is 1. So our answer is x to the negative 100 times x plus 1 times the quantity x squared minus x plus 1 times the quantity x cubed plus 9. Okay, one last problem and then we are done. All right, our last problem is x to the 7 halves minus 7x to the 3 halves minus 18x to the negative 1 half. Okay, this is like, if you can do this one, you can do them all. First of all, we have an x to the negative 1 half is our smallest exponent, so that's our GCF. So when we factor this out, I'm going to write this in because I don't want to make a mistake. Existing exponent minus the exponent we're going to take out. So x to the 7 halves minus 1 half. That means we're doing 7 halves plus 1 half, which is 8 halves. So that would be x to the 4th. Okay, minus 7x to the 3 halves minus a negative 1 half. So minus a negative is plus. 3 halves plus 1 half is 4 halves, which is 2. Okay, and then finally, the easy one, factor out an x to the negative 1 half from an 18x to the negative 1 half, and you just have 18. Cool. Furthermore, we have quadratic in form, so I'll show the substitution. R is x squared. If you don't want to write in what I have in green here, r is equal to x squared, so r squared is x to the 4th, making this r squared minus 7r minus 18 instead. Everything I'm writing here, before I go back to x's, everything I'm writing in green, You don't have to show if you want to skip these steps. But this factors two numbers that multiply to be negative 18 and add to be negative 7, or 9 and 2. The 9 should be negative and the 2 should be positive. Okay, so we have r minus 9, r plus 2. Okay, so r was x squared. So this is x to the negative 1/2, x squared minus 9, x squared plus 2. Now, we haven't done difference of squares in a long time, it feels like. X squared plus 2 is the sum of squares, and we discussed that a few lessons ago. That does not factor anymore, but x squared minus 9 definitely factors. It factors to x plus 3 and x minus 3. So we have x to the negative 1/2 times x plus 3 times x minus 3 times x squared plus 2. All done.